All right, my friends, I wondered if you noticed the relationship between Pascal's triangle and the expanded versions of our answers. And then once we clarify what that is, then we can start using it in a really meaningful way to skip all sorts of steps that we'd normally have otherwise. So probably the most obvious relationship would be the values that you see here. And if you count the rows, this is actually 1, 2, 3, 4. That's the fifth row in Pascal's triangle. However, I prefer to think of it as the fourth degree row. And then the next one would be the third degree. The next one up, that is. Second degree. And then first degree. Oh man. And the top one would be the 0 degree. Okay, so if you notice, you've got 1, 4, 6, 4, 1. And what does that have to do with anything over here? Well, if you look at the expansion of a plus b to the fourth power, 1, 4, 6, 4, 1 ended up being the coefficients in your expansion. And let's make sure you're good. So 1, 3, 3, 1. Well, that would be the coefficients in the expansion of the third a plus b to the third power. So you got 1, 3, 3, 1. The 1, 2, 1 that you see over here on the right side, that would be the expansion of a plus b to the second power. So 1, 2, 1, those are your coefficients. The 1, 1 for the first degree row. 1. Oops. Oh no. Yeah, 1 and 1 here. And then the 0 degree row, you just have a single 1. There you go. And so a lot of people think, well, okay, awesome. That helps me with the coefficients, but what about the rest of the stuff? Well, notice the rest of the stuff has its own pattern. So for example, if you look at the expansion of a plus b to the fourth down here, the power on a, your first expression in the binomial, starts at 4 and then decreases by 1, 3, 2, 1. And then you even have like an a to the 0 at the end, since anything to the 0 is 1. And then your powers on B start at 0. Technically, there's a little b to the 0 down here. And then increase by 1. And then you'd have, there we go, b to the fourth. So, and that happens in each of the expansions, right? So your expression A is cubed, and then to the second, to the first, and then to the 0 at the end. And then the B starts with b to the 0, b to the 1, b squared, and then b cubed. For that. So anyway, so there you go. Now you know the trick. All right, so let's practice using this. So example 1. The directions in your textbook when you do this problem set will say use the binomial theorem to expand each expression. Now, I'm not going to talk about the binomial theorem until part 2. So when you see in the part 1 problem set, when you see binomial theorem, I want you to interpret that as using Pascal's triangle. And then we'll talk about the binomial theorem in part 2. For now, just enjoy the beauty of Pascal's triangle. So let's say I give you an expression like 2x plus y cubed to the fourth power. So I'd like for you to see if you can use the shortcut that we talked about in the warm-up to expand this and not need to use the distributive property on it. If you don't fully understand it yet, I say that's okay. Throw something at it. Maybe you'll get it right. And if you don't, maybe you'll screw it up, but at least you'll get that, kind of get that itch scratched before you're in the middle of a test, So go ahead and do what you're going to do with it, and then check in with me in the next video.